Hi everyone. So in this lecture, I'll explain the Quine McCluskey minimization technique. Why we need Quine McCluskey minimization technique is if we go with large number of K-map, then pattern recognition of group forming is very tedious job and little bit ambiguous. For that reason, Quine McCluskey minimization technique helps you to minimize for the large number of variables or min terms. So first of all, what is the procedure? Let me see once. Then we can start with the example. So Quine-McCluskey minimization technique will deal with in three steps majorly. The first one, whatever the given terms, so we should arrange all the min terms given in the ascending order. Make sure that the number of ones being present in the groups formed should be the same. So I'll let you know what actually it is in the next slide. So compare all the elements of group n with group n plus 1 for a logical adjacency. Then replace that variable by dash if any logical adjacency is there between the groups, between the cells. Then you'll replace that with dash. Then it forms a group of two cells. Then all of the adjacent minterm groups contained in the step 2, what you have a table of it. Then you compare to see if the groups of 4 can be made. The criteria for forming the groups of 4 are as follows. The dashes in the groups of 2 must be in the same bit position and only one variable change is allowed. That's what we call it as logical adjacency. Repeat this process if until you get all the possible groups of higher elements like groups of 8, groups of 16 if possible. All of the prime implicants are formed into a prime implicant table by covering all the minterms given at the top row. Make sure that obtained prime implicants cover all the minterms given in the question. If any minterm is missing, find suitable prime implicant covering that minterm. Let us take example and let do solve. So solve using QM method. So the given expression is D, that's a function of A, B, C, D. That is summation of 0, 1, 2, 3, 6, 7, 8, 9, 14, 15. So now I'll form the very first procedure is arranging all the minterms in ascending order. Okay, so I'm taking 0, so 0 here. So write the binary equivalent of it, then 0. So it does not consist any ones in its binary representation, then it forms a separate group. Then I'll go for 1 and 2. I'll directly jump to 8 because where 3, 6, 7, their binary equivalent consisting 2 or 3 ones, right? So let us group 1 and 2. Along with that, 8 will comes to a group called as, which is having only one number of ones in the binary representation. Okay, then so similarly 3, 6, 9, so they belongs to group of 2. Okay, then you go with the procedure 9. So sorry, 9, 7. So 7 is having 0, triple 1. So 0, triple 1 means 3 number of ones are there. Then for 3 number of ones, if any other min term is given, 14. 14 also belongs to 3 number of 1 groups. So you can form like this. Okay, then last one is 15, which is having 4 ones. So in such a way, you should order the given Boolean expression or this expression to solve. So then table 2 will be formed by looking at the table 1 once again. So which will give you group of 2 cells. So how? Let us check. So where if you treat group 0 as group n, then you need to compare all the elements of group 0 with group n plus 1. So that means group 1. Okay. So now 0 is compared with 1. So only D is variable. All other 3 variables are same. Then it forms a group called as logical adjacents 0, 1. So similarly 0, 2. So this cell and this cell only the variable change. So that will be replaced by dash here. So similarly wherever you will get like logical adjacency, you replace with dash. That's what the rule of QM method. So 0, 8. So 0, 8, you just look here, only one variable change. By observing the dash in the min terms, make sure that, so if you place 0 to the dash, then it will form a cell 0. If you place 1, it will give you the binary equivalent of 1. That's what the verification at the time of placing the dash in the logical adjacent cells you need to make sure. Then I'll proceed with group 1 and group 2. That is 1 with 3. 1 with 3. So the C variable is going to be the logical adjacent cell. So 1 with 3. So this is what the dash I got. Okay, then 1 with 6. Here 1 with 6, 0, 0, 0, 1. So here there are two cells are varied, it won't be coming to picture because it's, so if we have only one variable change, then we call it as logical adjacent. Then 1 with 9. So 1 with 9 is possible. So because A, if you change A value, it will become 1 and 9. So make sure that will be replaced by dash. Then 1 is over. Then compare with 2 and 3. 2, 3, which is also possible. D is logically variable, logically adjacent cell. And 2 with 6. 2 with 6 is also possible, where B is logical adjacent cell. And 2 with 9, which is not possible, okay, because if you compare 2 with 9, so you can observe that there are more than one variables are changing, okay, so then it won't come into picture. Then I'll go with the 8. So 8 with 3, which is not possible. 8 with 6, which is not possible. 8 with 9 again, so which is also possible. I have taken here, you can observe. So this is what the D is, a logical adjacent cell. Then I'll proceed with group 2 and group 3 here. That is called as 3 with 7. 3 with 7 is possible. Yes, 3 with 7 is possible because B is logically adjacent. And 3 with 14. 3 with 14 is not possible because it's having two number of variables. Then I'll proceed with 6 and 7. So 6 and 7 is also possible, only D is variable. Then 6 and 14. 6 and 14 is also possible, where A is logical adjacent. Then 6 with 6 is over, right? Then 9 with 7. So 9 with 7, which is not possible because so many variables are changed. And 9 with 14. 9 with 14 is also not possible. Then I'll proceed with group 3 and group 4 here. Okay. So 7 with 15, which is possible because only A is logical adjacent. On 14 with 15, of course D is logical adjacent. Okay, so now you got one more table called as grouping of two cells. Okay, now let us proceed the same procedure with group of 4 and look at the 0, 1, 2, 3 expression, that is A bar and B bar. So A bar and B bar written here. So which is forming your 4 cell group, that is A bar, B bar covering 0, 1, 2, 3. Similarly for 0, 1, 8, 9, this is B bar, C bar, and 2, 6, 3, 7, it is A bar, C, and 6, 7, 14, 15 is B, C. Okay, look at the previous table and look at taking the binary equivalent expression for it. Okay, then so here first group 0, 1, 2, 3 is covering 0, 1, 2, 3. So similarly 0, 1, 8, 9 for second group. Okay, so similarly 2, 3, 6, 7 is for third group, and for the fourth group it is 6, 7 and 14, 15. So after writing that and place X wherever the minterm is being covered, now look at the column wise. Look at the column wise. If only one X is there in the entire column, then they are essential prime implicant. Excused. They are exclusively grouped. That means their cells are essential prime implicant. Now looking at their the binary equivalent or minterm, which covers all the elements in the minterm given. Okay, so make sure that 0, 1, 8, 9, 6, 7, 14, 15. So 0 is covered, 1 is covered, 6 is covered, 7 is covered, and 8 is covered, 9 is covered, 14 is covered, and 15 is also covered. 2, 3 is not at all covered by this group of 4 cells. Now let us look any other group which is possible to cover 2, 3. So then 2, 3 is there here, and 2, 3 is also there in the other group too. Okay, so now you can take any of that group as a essential prime implicant to cover 2, 3. Okay, so it's so important point to be remembered, because so many students will stop the entire process at this point itself, then answer might be wrong. Okay, make sure that once you form the group, so you cross check with the minterms given, then all the minterms should be covered. Then only whatever the valid expression you are giving, solution is giving, it should be covering all the minterms. Then you can write a bar, b bar, or a bar, c in your answer, then which gives you the correct answer for QM method minimization technique for the question given. Okay, so let us solve one more example which is having so don't care term also. So let us second example that is given with the don't care term, that is L is equal to function of a b c d, that is 0 1 4 5 7 8 13 15 along with the don't care at the midterm 2. Okay, so arrange all the midterms given in ascending order by covering the number of ones being covered. Okay, so make sure, so for the 0 binary representation 0 0, which is not having only one single one in the binary representation, then 1 2 4 8 they are having one in the logical one in the binary expression, so which should be form a separate group. Then 5 just being 0 1 0 1 because the only one element which is having two ones in the binary representation. Another one is 7 13 15. So 7 13 will form other group because three number of ones being present here, right, by observing. And last one is 15, which is having four number of ones. So now the first table, for the second table, let us have the comparison here. You just observe. So group n should be covered with, compare with 0 and 1, right? So 0 and 1. So group 0 with group 1, all the elements should be compared. So 0 1, which is forming logical adjacent group because D is logically, and 0 with 2, again C is observable, that is also varied. Make sure that it's appended with star, then it means that which group is forming with D. Okay, so then make sure once again, so 0 2 is over, 0 4 which is also possible, only B is variable. Then 0 8 which is also possible, only A is variable, right? So one comparison is over. Then compare group 1 with group 2, that is 1 with 5, which is possible because only B is variable, right? So 1 with 5, we can just check. So fine. So then group 1 is over, group element 1 is over. 2 with 5 is not possible because 2 is variable, and 4 with 5 which is possible, we lost one, that is D is going to be varied, append with the dash. Then 8 with 5, 8 with 5 is not visible because two cells are varied at starting itself. Then 5 with 7, let us start with group 2 and group 3. 5 with 7, this is possible because logically variable cell being present at the C. Okay, so C, just check. Okay, once again, fine. So then 5 with 7 is over. 5 with 13, so 5 with 13 means it's also possible. 5 with 13 with logical cell of A. Okay, 5 with 13 is also done here. Just check once again. 7 with 15, which is also possible because A is variable once again. A is varied. Okay, so 13 with 15, 13 with 15 with B is logically adjacent cell. Sorry, C is logically adjacent cell. Okay, then let us form the group of covered. Okay, so here you can go with to the group of two cells where 0, 8 is being covered, right? Then this group of two cells should be present at the final expression or the final solution. So answer is B bar, C bar, D bar. So which should be added to the answer. You can do that. So A bar, C bar, A bar, C bar, which covers 0, 1, 4, 5, and B, D, which covers 5, 7, 13, 15, which already saw, right? Then 8, which is being not covered, but we have looked the previous table covering for the minterm given, that is B bar, C bar, D bar. Okay, so which covers group with 0 and 8, so which cover the minterm given. Make sure that if you don't cover the don't care term, it's okay, but all the minterms given in the expression should be covered. Okay, so since the given expression 0, 1, 4, 5, 7, 8, 13, 15 are the minterms given, where 2 was don't care term. So don't care term you can omit it, no issue, but so minterm should be covered. So this completes the explanation of minterm with the QM method with the two examples, suitable examples. I hope you understood. Thank you for listening.